Hello, this video is going to cover sort of an introduction to interactive challenge sets. Interactive challenge sets are much different than like a game that would have you practice skills. Interactive challenge sets challenge students to sort of work on conceptual understanding, to answer open-ended questions. Um, and it allows them to play around in the geometric playground that is GeoGebra. So you can have them doing some construction, you can have them sort of manipulating figures, and then responding with open-ended questions. So it's a really good way to allow students to get their feet dirty or their hands dirty, in geometry, in real geometry. So this right here is the template, basically the template that I would use to make a geometric, an interactive challenge set. And if you notice, I'm grabbing this and I'm trying to move it, and I can't. The reason why I can't move it is because this is my no movement template, and I can't emphasize enough that when you make an interactive challenge set, that you do set the limits of your template so that it won't move around, and so that they can't zoom in, zoom out, or move it to the left or right. Because if that does happen, or it's allowed to happen, kids can lose their work, whether it be by accident or intentionally, and it just can create a headache, just a mess. So you do need to make sure that you put the limits on your template. And just to review, this is where you would do that. I basically found out what the limit of this was. Initially, there were numbers here, 4 numbers right there, and there. And then I took a screenshot of it, and then I said, I made numbers in the input box down here, and I made it so that they would be those numbers. So if the left side was at negative, let's say 10, then I said, let's set b equals negative 10, and then I put b there. So that means that left side of my template will always be negative 10, and so on. So that's how that is done, and it's important, again, to do that so that the assignment is stable. The other thing that I have on this, as you can see, is this lever. Now this lever is just slider. The idea is that you are going to decide how many open-ended questions you want, and then however many you want, that's how many that's the range of your slider. So for me right now, I have this ready for 5. You could change it to 3, to 5, 6, whatever you want to do. But this is sort of the basically, this is the way it should look to start. And from there, you're going to put text for each open-ended question, and you're going to attribute them to a equals 1, then the next one to a equals 2, and so on. And also with the diagrams as well, you're gonna have them show up only for that a equals 1 in condition to show object. So let me show you a few examples that I came up with that I like. One of the things you can do with these is that you can provide immediate feedback too, so that kids can tell if they're on the right track. So for instance, this is a really basic topic of triangle classification, but I wanted them to make right triangles, so they would move these points around, and when they get over there, they know that they're correct. So then they would just have to make a text. They could put it here, and then they'd be correct. I'll show you another one. See that triangle in the question move, but that's because I attributed the text in this to a equals 1 in object properties. Like if I go here, you'll see object properties, this right here. If I go to advanced, this is what I put a equals 1 for all of this right here, so that it's stuck for a equals 1. I did the same thing for the text, although I made it so you can't even select it, just because I don't want anybody to select it, and then you can just press delete and it'll be gone. So this is the idea for this one. The other thing is, when kids do create something, I'll show you this. I can show you this later, I think. They themselves also have to go in here and go into object properties and and click on that whatever it is they made and attribute that to equals one, and that makes it so so that their work will show up for each part of the assignment. Like for each one of these, they'll have work show up. I'm going to show you an example of this. So that's also the feedback there. Here's another example of feedback for this one. If I the challenge here was turn this into a rhombus, which means these diagonals would need to be right angles. So in order to do that, you'd have to make perpendicular lines. You'd have to make these perpendicular. Put a point on this, and then once you do that, you just find out what the name of this is, which you open up, and that's v_1. So then you know what that is. So you just say, click on this, and you say, well, we just need the location of this to be v_1, and you press OK. And now, once I do that, it turns red, which is an indication. I always tell them that they're correct, and they like to know that they're on the right track with their construction. So it's nice. I mean, I did the same thing with this one right here, and if you notice, that's still there. So if a kid was creating this with the construction, they would have to select this right here, and then go into object properties. Where is it? Object properties, and they'd have to say for that, they'd have to say A=1, which I think is a valuable sort of thing to have them do, because it's a little bit of logic involved. Like they have to know, okay, well, what is the condition that I wanted to show up only when A=1? You know, so I like that. I like that part of it. It's an extra layer of work that they have to do, but I think it's worthwhile. This is a square, so for this one, you'd make a circle going from here to here, which would go like this, and then you'd also make perpendicular, drop it off here, and have there'd be one intersection where that circle would be with the line, and that intersection is where you would put this point. So it's another sort of opportunity for construction. And then this last one is on isosceles triangles. I just want to show you a few of these. This triangle looks to be identical to this triangle, the 120.8, 120.8. But if you notice on this one, if I move this, the base angles are right here and right here, whereas the vertex angles right here. But you can tell that by the way I move this. Whereas if I move this, this doesn't move, yet this one does like that, and you can tell that now this is the vertex angle, and these are the base angles. So there's all sorts of things like that you can do on GeoGebra, but you can't do it on paper. I mean, if you gave those two things to someone on paper, they wouldn't be able to make sense of it. But since they can manipulate it, they can. So I like that. This last thing that I wanted to show you is just one of student's work, and this was actually, if you notice, this is the work from the thing that I just showed you, where she wrote an explanation for this one, and she was able to identify that those are the base angles, and then for this one, she saw that these two were now base angles, right? So, and her explanations are right there. And then the last one, she created this all on her own, just based on these instructions.